Okay, so here we are. So now what questions do you have about this? Do I mind going over?
Well, to find the theta, essentially we need to draw a triangle, right?
You do not need to draw a triangle to get the answer. Okay, I know a lot of you right now are now focused on the sheet in front of you and you're talking amongst yourselves to complete it. Please don't. If you want to work on it, just be quiet and do it. Thank you. So, do you need to draw this chart out and chart the answers we had, which was x of t ended up being 30 point something. What was it? 34.9. Okay, and this was 200. Do you need to draw this out? Absolutely not. No, you don't. I do it in my mind, just so I could see that's 34.9, that's 200, so I can visualize what that triangle would look like. If this were 34 inches by 200 inches, I would know that it's going to have a very shallow angle, and so this angle of theta is not that much. But I ended up with an answer of 200 by 200, then I would know that it's going to be about a 45-degree angle, right? And so that helps me when I get my answer. Did I get close or not? And the same thing, somebody asked me, well, if x of L is up here and x of C is down here, do I actually need to draw x of C down here on the bottom? I mean, because if it was a capacitive circuit, which I didn't even give you an example, and we ended up with negative 34.9 because x of C was bigger, then it's actually down here 34.9 and the triangle goes this way. It doesn't matter. You're still going to get the same angle. You seem lost. Or
no, because, can we go back up to the formulas?
Yep, back to the formulas.
So theta is tangent to the -1 over opposite and adjacent. Adjacent.
It's always going to, yeah.
So I know this is stupid, but what's opposite and what's adjacent?
Oh, okay, that's not stupid at all. When you're looking at a triangle and you're trying to solve for this angle right here, this is the adjacent. And this is the opposite side. Because remember we had our choice between tangent, cosine, and sine. And each one of those had a different thing. And I selected, or as a class, we decided to go with tangent because it's the only one that doesn't have opposite. So, see, I can't do that. Is it S? Yeah, it's S. So, I'm not even going to make it. So, yeah, SOHCAHTOA. I was trying to do it real quick. But the other ones use the hypotenuse, which is Z. Z is a whole nother step. So if you mess up on Z, you're going to mess up on everything. So I brought it back a step and said if you use the arctangent, it's one less layer of probability of making a mistake. So that's your best one to use. But you could have used any of them. In fact, in other classes, on this sheet right here, I've actually did that. Instead of having just, let's see, angle of theta tangent right there, I would actually, and I'll do it if you want. Let me see. But I'm going to make sure I do it right. Unless somebody, because I don't have it memorized, because I always use tangent. Who's got it real quick? There it is. So we could do sine. We got black. Sine equals opposite over hypotenuse. So COHCAHTOA, cosine, equals adjacent over hypotenuse. And tangent equals opposite over adjacent. So I could have picked any one of these to get the angle. Any one I wanted. If I want sine, I just use the opposite hypotenuse. This is the opposite, is always going to be the opposite from this corner, and this is the hypotenuse. If I wanted to find this angle, then well, I don't want to do that. I'll just confuse you. This is the angle you want, so stick with that. So, got it?
Yeah.
I can use any one of those three once I have them, but your best bet is tangent. Yeah.
Can you use one of those just to double check?
Yeah, absolutely. I'll leave them up there. Yeah.
What is frequency there? XSIC?
I don't know. Why do you want to know?
How we can
What?
find the R result?
What's the frequency of what?
Of
AC circuit.
of the IC battery.
60.
60. Good.
So
0.3.
So we can write here frequency 60, right?
Yeah, but why?
But how we can?
Why do you want the frequency for that? Why are we off on this tangent now?
But you need.
Yeah, you can write 60 on there, and you can change the battery to a circle, and you can go on the internet and complain. So, all right. So back to reality, where people actually care. What else can I do for those of you who are paying attention and don't need weirdness? Yes.
Just there. I was gonna ask you for the answers
Uh,
of the second problem, that's all.
I-
'Cause
I-
you didn't record it, that's all.
Oh, didn't. Okay, I'll write them real quick. I'll write them real quick.
Can we use this
Which-
capacity like a resistance?
That's what you're supposed to know. Okay, I believe this was it. It was 220 volts, 1.5 henries. What was my capacity? 5 microfarads. Is that the right one? Did I pull up?
Yeah.
Okay.
200. Yeah.
All right. So X of L equals 564.487 ohms. X of C equals 530.516 ohms. X of T equals 34.971 ohms. Z equals 203.034 ohms. I equals 1.084 amps. E of R is 216.8 volts. E of L equals 612.988 volts. E of C equals 575.079 volts. The angle of theta equals 9.918 degrees. Power apparent equals 238.48 watts. Power true is 235.011 volt amps. And the power factor equals 0.985.
Thank you.
You are welcome. All right, so you have the AC series handout, which gives the opportunity to do 10. Seriously, if you want to just write answers in here and get it checked, I'm happy to do it for you. See me tomorrow. I'll probably just bring in the answer sheet, pin it to the board. You can look at it and figure out if you got it right or not, okay? Want me to leave that there for a minute? All right.
Well, sorry, I'm gonna ask a question, but will all the ohms be the same and the amps will be the same towards the letter and volts and everything? Does that make sense?
Nope.
So like XL will always be an answer?
That's like, is resistance always in ohms, or is resistance sometimes volts?
Yeah, that's what I was like, okay, that's a good question. but
It kind
I just wanted to make
of, it's
sure.
not. You have to know what X of L is. X of L is a form of resistance, therefore it's always ohms. X of L can't be volts because it's not. Okay, so I'm going to move on. with the little hour and a half we have left,
Uh,
I want to cover something here that I went to kind of, this is impromptu, so I don't know how well it's going to work out, and I just found this really quick online, but I'm seeing that, well, for lack of a better word, y'all don't want to read the books, and you're just hoping and guessing to get this right, and that's not working. So when you're reading the oscilloscope, and I don't think I can write on this, so there's going to be a problem because it's actually online. The vertical, so you need to make some notes. The vertical measures what? It doesn't measure amplitude.
Why is right? Huh?
He's right, but we got to say it so everybody understands. So if we say, and you're not wrong, but if I say the vertical measures amplitude, how many volts is there? They go, oh my God, I don't know. You didn't tell me about volts. You told me about amplitude. I can measure the amplitudes. So there's 4 amplitudes. Is that like resistance? That's XFL. All right, so the uppy down is going to measure voltage, or I suppose if you had it set for amps, you can measure amps. But the problem that I'm seeing, number one, okay, so the oscilloscope book that you have, the directions state very clearly, read from the top to the top. And it's amazing how many people don't know top from bottom. Because you think, well, from the top, which is right here, the top, I'm using the top of the arrow, top of the arrow here, to the top of the bottom. Well, that's down here on the bottom. And I'm like, where's the top of the table? Here. Are you sure? No? This is the top. I'm like, wow. This is the top down here under the table. So if you want to follow the manual, and the reason why is because this line has thickness, all right? If you want to follow the manual, then fine. It's top to the top. You can't go from the top here and add the thickness to the line to the bottom. That's not accurate. If you have a very nice little pencil thin line here and you want to read right in the middle of the line, knock yourself out. I don't have a problem with that. All right. I think that's actually the way it's done out in the field. So when I look at this, remember that you can move around the sine wave. All right. I haven't changed the values. I can go right and left. I can go up and down. I haven't changed anything. I just get to put it where I want it. So if I want to measure, let me see, can I do this? Yeah, good. I want to measure the voltage. I've got this on voltage. I want to measure the voltage. I want to measure it. Okay, here's one of the problems. I say, well, what is the peak voltage? What is the peak? Oh, well, that's easy. This is 0, so that's 1, 2. Well, it takes up the third block, so I have 3 volts. Am I right? Okay. Well, or it's 1, 2. I actually had this 1, 2, 3 lines. No. All right. Another one. Okay, this is 0. This is 1. That's 2. Am I right so far? Okay. Now you got this little bit of change here. You can't just ignore that. It exists. And so how do I do that? I move it over to right there. And each one of these little tick marks counts as how much? 2, 4, 6, 8, 10. So each one is 2. Well, it's not quite 2, is it? So what could I say? It's 1, 2.18. I love 2.18. Okay, so I can't write on this. So 2.18. Am I correct? No, of course not, because the whole sine wave was arbitrarily placed up and down. I just simply placed it up there. How much do I have going down? 1.5 or 1 3/4. So I got 2 point something up and 1 point something down. Is that the way a sine wave works? No. You cannot do that. All right? So what you have to do is line it up to make sense. All right? Oops, I don't want to change that one. Where can I go? Horizontal offset. So what I would do is I will pick the bottom, I'll move this out, and put the bottom loop somewhere that makes sense. And if I can get it to go down far enough, I'm going to put it right there. Everybody see that? So I've got it right here on the bottom. I'll do it here. I've got it right here, and I just put it on this line here. Why did I pick this line? Because I wanted to. I do anything I want. I'm the master of this thing. So I put it right there. Now I'm going to count going up. 1, 2, 3, and some change. Well, it's kind of hard to read that, isn't it? So you know what? I'm going to go to my vertical offset, which horizontal. And I'm going to move it over till it doesn't move quite enough. Your oscilloscope moves better. But now I can read it. Try it again. 1, 2, 3.246. 3.8. Okay, so we'll call it 3.8. Now, that's great if the dial, which I don't think I have on here, says times 1. What if it's times 2?
Then you multiply the answer by 2.
Literally, just multiply it on your calculator times whatever the dial says. The dial says times 5, multiply it times 5. So just count this. You guys can count. We've watched Sesame Street. 1, 2, 3.24682. 3 point. So just do that, and then there's going to be a dial on the side that says volts per division. What division is it talking about? Is it talking about a division here? Or is it this division? It's the big squares. That's the division going up. So if it's times, every one is 5 volts, then it's 5, 10, 15. It'd be 20 to this one. That's kind of hard. So again, I like to count by ones and just multiply it. And I don't care if I'm not going to make fun of you if you get out your calculator and it says volts per division times 2. And you're like, all right, 1, 2, 3.8. 3.8 times 2 is, and you look at it, 7.6. You know what I'm going to say? Good job. I'm happy about that. It's the right answer. I don't carry a calculator. All right. So up and down. What is that again? Volts, or if you're measuring amps, which I don't ask you to do. So for the most part, your project, that's volts. Now, right and left. What is right and left?
Hertz.
That is your hertz. That is your frequency. All right. So how am I going to measure frequency? Well, there's a couple ways you can do it. You can move your horizontal offset until you get a peak right on that. I don't like that method because, well, it's a little ambiguity there. Is like that perfect, or is that the perfect one? Maybe that's perfect right there. So sort of what I will do is I will get it and line up right here. If I've got that point right there, let's try it. So 1, 2, 3, 4.24.
5.
Well, if you're really, really good at something, you can just kind of stretch it out a little bit and make it work for yourself. So that actually didn't work very well. All right, try it again. I'll get back here. What do I got? 1, 2, 3, 4, 4.8.
8, 5.
Well, let's say 4.9. Okay, 4.9. Now, what if I didn't have it quite right? What if I was offset like that? Does it still work out? Oops.
Yeah, it does.
Now I'm picking down here. 1, 2, 3, 4 point. Doesn't matter. So I can have it up, I can have it down. As long as I'm picking 360 degrees later, I'm good to go. Okay, now this is a little bit different because you have, this is reading what? It hurts, but what is my actual divisions in?
By microseconds, milliseconds.
Time. Okay, in time. That's very good. So there's the time. So you guys that are working the project or just finished it, what would be what was your setting at in this particular one for one of these? Would you have the time division on? Give me an example.
2 milliseconds.
2 milliseconds. So each one of these is 2 milliseconds. Each one of these is 2 milliseconds or each block? It's always in blocks. The dials talk to 2 milliseconds. So how much we got here? 1, 2, 3, 4.9. So this I got 4.9, and it was in what?
2 milliseconds.
Okay, so multiply it times 2. Again, I'm going to preach this one. Milliseconds. E to the what?
Negative
-3
30.
equals, and so I get 0.0098. What does that mean? 0.0098. One wavelength, one 360 sweep, took me 0.0098 of a second. Now, How many hertz is that?
Oh, I know.
0.0098 hertz? Thank you, Steve, for participating. I like this guy. I was hoping somebody would say that. It's not. It's how many seconds per cycle. What is hertz?
Cycles per second.
Cycles per second. Different. So once I get this, there's a little key on here that converts it. It says frequency. Actually, it says frequency right there. I just noticed that. I didn't know the frequency. You just hit the 1/x. It just so happens that it says freak right there. I don't know what that key is. Anyway, hit the 1/x. Hit the 1/x. I have 102. Now, what is my hertz?
102.
102 is my hertz. How about that? All right, everybody follow that? I'm going to have Tom do a YouTube video on that. Why are you laughing at me?
About 45 minutes to an hour.
Because he's gonna start that and he's gonna go off on some other bullshit thing that he used to do, and then he's gonna come back and he's not even gonna answer it.
All right, preview.
Now, if you have problems with this, if you have, I was just looking what else it was, so I just picked this up. If you have problems, make sure number one you read the manual first. No names, but it's a good student who was brave enough. I said, "Where'd you get these answers?" I YouTubed it or Googled it. The right answers, but you missed reading the book that's in Canvas, which explains so much of this. All right, so make sure that you're reading the right stuff. So, and one thing I guess we haven't talked, but what's your goal for being here?
Learn.
To what?
Get an A&P.
To get an A, and what are you going to do with your A&P?
Work on aircraft.
Okay, if you barely make it out of here and you get more or less a mercy pass, how valuable are you to the industry?
Depends how much you learn.
Nothing. That's my point. A mercy pass, which is basically a C- student who somebody said, just give him the freaking C and get him out of here because we're tired of looking at this person. How valuable are you to the industry?
Not very.
How much money are you going to make? Let's screw the industry. How much money are you going to make as a C- graduate of the program?
Well, at Rite Aid, you make about $14 an hour, so I'd say about $14 an hour.
At Friday?
At Rite Aid.
Oh, Rite Aid. All right. Best answer ever. So you understand that?
McDonald's.
So you'll make $14.95 an hour working at slinging ice cream, right? And you hated doing that, didn't you?
Hated it.
You hated it. All right. You're here for your future, and I know I'm not talking to everybody. Some of you, but some of you need to kind of think about this. If this is your future, you got to learn it, because once you get out in the field and you don't know it, you're going to be asked to put your toolbox back in your truck and leave. So that's just a fact. All right. So thank you for letting me get on my soapbox. So don't.